Okay, so this is proportions with two terms. Okay, so we just learned how to do regular proportions when there was just one term in each spot. Now we're going to deal with when there's two terms, at least in one spot, if not more. Okay, so here we have x plus 5 on the top of this fraction. This is where the two terms comes in. But we still do the same exact thing. We just want to keep this together. We want to treat it as if it is one term. And we're going to do the same exact thing that we did before. We are going to cross multiply, right? And I'm just going to make it say CM, okay, for cross multiply. So if we cross multiply, I get 4 times x plus 5 equals 8 times 6. And what's 8 times 6? Well, 8 times 3 is 24, so times that times 2, we get 48, right? So if we look at this, I have a distribution. So my next step is to distribute. So 4 times x, I get 4x. 4 times 5, I get 20. Okay, that equals 48. So still haven't done any real manipulation, but you can see that we've real quickly gone from something that looks really confusing into something pretty simple. I'm just going to keep going here. If I subtract 20 from both sides, I get 4x equals 48 minus 20 is 28, and then I divide by 4. I get x equals 28 divided by 4. Well, 24 divided by 4 would be 6. That's 7, right? So x equals 7. Example number 2, well, first one we had x in the top, now we have x in the bottom, but everything goes exactly the same way. You can see that it looks a little bit different, but we still want to do the same exact thing. And I just like to put the parentheses on first, that way I remember that I'm multiplying everything, and that way I don't forget. So I have 3 times x plus 1, and that equals 2 times 8. That one's a lot easier, that's 16. Again, I distribute. 3x plus 3 equals 16, and now I'm actually going to start manipulating. Okay, so 3x plus 3, again I want to get this term by itself, so I need to get rid of this one. I'm going to subtract 3 from both sides. If I do that, I get 3x equals 16 minus 3 is 13. Now I'm going to divide by 3, and 13 divided by 3, that doesn't work out so well. But that's okay. You're going to get fractions in these. It's very difficult to come up with an equation that always gives you a perfect whole number. So as long as you look back and you can see that you did everything correctly, you cross multiplied, you distributed, you solved, you should be fine. And if we could simplify that, I would, but 13 and 3, there's nothing that we can reduce to. So we're just going to leave our answer as that. Okay? So let's take a look at some more examples because they do get harder. Example number 3, we have x plus 5 over 5 equals x plus 9 over 4. So now we have two terms. Okay, same exact process though. Just now it's just going to take us a little bit longer. So I'm going to do the same exact thing as I did before. I just have more steps to do. So 4 times x, I get 4x. 4 times 5, that's 20. 5 times x is 5x. 5 times 9 is 45. And now I'm going to combine, or I'm not going to combine like terms. I'm going to get all my x's on one side, and I'm going to get all my numbers on the other side. And actually, since this one's smaller than this one, I'm going to put my x's on this side. So I'm going to subtract 4x. Okay? And to save time, I'm actually going to do something kind of crazy here. What I'm going to do is I'm going to move the numbers at the same time, because if you notice, this makes a 0 and this makes a 0. I can do both of these at the same exact time because all I'm doing is adding and subtracting. And since this only applies to these terms and the 45 only applies to the numbers, then I can do them at the same time. So 20 minus 45 is negative 25, and that equals x. So I actually found my answer there. So you can see it looked like a lot of work, but if you can find a shortcut or a way to cut down on the number of times you have to rewrite the equation, I'm going to be okay with that as long as you're showing every step that you're doing, okay? Example number 4, now we have 2 on the same side, but same thing applies, okay? It's not going to change anything. First step is I'm going to cross multiply, and I'm going to put the 8 on this side. So I have 8 times x minus 8, and that equals 4 times x minus 9. Next step is to distribute. 8 times x is 8x. 8 times 8 is 64. Distribute here, I get 4x minus 36, and same exact thing. Now I notice that this number is larger than this one, so I'm going to move my x's this way, and I'm going to move my numbers the other way. Oops, not 46, I want 64. So again, looks like a big mess when I draw it, but if you're careful and you can see where your zeros are, you know where your simple stuff is here. So 8 minus 4, that is 4x, and that equals negative 36 plus 64. Usually what I do in this case, since I have a negative and I have a larger positive, I actually change it up. I make it 64 minus 36. And 64 minus 36, well, I'm going to have to borrow 14 minus 6, that's 8. So 8's my number there. 5 minus 3 is 2, so I should get 28. And if we divide by 4, we get our last step. X equals, and again, we get 7. Interesting. So some of them we get whole numbers, some of them we're going to get fractions, but you can see as long as you have 2 terms, it's pretty simple. The steps are pretty much the same. It just depends on how complicated the problem is. But the first step is always cross multiply. Second step is probably going to be distribute because you're going to have 2 terms. All right. So this has been proportions with 2 terms.